How's everyone doing? So this is the Chapter 4 presentation video. The complexity of this chapter is going to increase a little bit. This is when you think of programming. In Chapter 1, they mentioned input, processing, and output applications. This is pretty much what we're going to be doing in this chapter. You're going to be creating applications where you enter some data into a text box, click a button, the application does some processing, does some arithmetic operations, and then displays some output for you. So the complexity, we're going to be working with variables, we're going to be working with converting some data and then outputting the data. So the complexity is going to get a little bit higher in this chapter, nothing that you guys can't handle. Should actually be fun. I'm also going to be doing something a little bit different in starting with this chapter. I've noticed with my previous presentation videos, in the first one I had 24 people that watched it. I'm looking at my YouTube hit count. The second one I had 14 people, and the third one I had 7 people. So it seems like it's trending downward. Some people aren't watching these videos. And I think going through these videos, watching them, it's very, very important because you're going to get the terminology. And I'm spending the time to create them, so you should be spending the time to watch them. If we were in person in school, I'd be doing these in the class in front of all of you, and you'd have to watch them. So I think people are taking a little bit of advantage. Some people are taking a little advantage of remote learning and not going through the video. So what I'm going to do is I'm going to embed some questions in the video. I'm just going to, somewhere within the video, I'm going to ask a question. I'm going to ask you to post those questions back as an assignment to the video. So I'll explain a little bit more of it when I post the assignment, but this is just going to kind of force everyone to actually go through and watch these videos of the PowerPoint presentation. Those of you that are doing it, great, shouldn't be any big deal. Those of you that aren't, there'll be a grade attached to the watching the videos. So hopefully that'll encourage you to watch these videos. Okay, so there's going to be quite a few objectives in this chapter. There's kind of a lot to it, so we'll just kind of go through the objectives. Every new chapter in this book, we're going to introduce a new object, and in this chapter, it's a text box object. So obviously, a text box object allows you to input data to the application, string data, numeric data, whatever it may be. We're going to use code to place data in the text box property of a label object. We've been dealing with label objects already, but just pretty much hard coding the values in there. Now we're going to use code to change those values. We're going to introduce a nice little user kind of user experience functionality of VB called the accept button and the cancel button property of the form. It's not, it's just something that will make your end user's life a little bit easier. We'll talk about declaring string and numeric variables and using assign statements to place data in variables. We'll talk about the difference between literals and constants, and we'll talk about scope for variables. We'll talk about converting string and numeric data back and forth, and we'll talk about some arithmetic operations and operators that we'll be using in this chapter. Simple math, nothing addition, subtraction, multiplication, division, nothing more complicated than that. We'll talk about formatting, displaying numeric data as a string. We'll talk about the form load event. We'll talk about concatenating strings, and we'll talk about debugging our programs a little bit more because in this chapter, our applications are going to get more complicated, so we're going to be more likely to have issues and bugs in our programs. All right. So when processing data entered by a user, a common requirement is to perform arithmetic operations on the data to generate useful output. Arithmetic operations include adding, subtracting, multiplying, and dividing data. So in the application we're working on this chapter, it's a bike rental application. So the user is going to enter a number in a text box for a number of days. So you can enter 4 days. You're going to click the find cost button, and the application is going to multiply 4 by the rental costs for a day, which is a $9.95 fixed cost, and the application is going to output the result of that. We're also going to code functionality for a clear button so that after the user has entered a calculation, they can clear out all the data and do it again, see what the cost would be for 4 days versus 5 days versus 6 days. And we're going to code the exit button, which you guys have done in previous chapters, so nothing much different there. Create this application, the developer must understand how to perform the following processes: define text box for data entry, find a label to hold the results of arithmetic operations, convert the data in a text box to data that can be used for arithmetic operations, and perform arithmetic operations on data entered by a user. So this is what the application that you're going to develop the guided program walkthrough. I'll create a video for this like I have with every chapter. So we've got a fixed cost of $9.95 per day. Our end user is going to enter the number of rental days, click find cost, and the result of 4 times 95 is going to be displayed in the label here. If they click clear, it clears out the text box and it clears out this label, and obviously exits out of the program. Pretty simple application, very simple math. It's just simple multiplication. So to design the user interface, we're going to basically just put text box objects, labels. There's a picture box in there too, and we'll talk about the accept and cancel buttons that we're going to use. So a text box object allows users to enter data into a program. The user can enter a value into the text box. So in this example, they're entering 4 in the text box. When the program is executed, the user can enter data in the text box. Users can enter letters, numbers, and other characters. Text box does not by default contain a scroll bar, so if a user enters more characters than the text box can display, the user must move the insertion point left or right with the arrow keys on the keyboard to view the data in the text box. And there's multiple ways we can get around that issue. For UI, we're going to keep our application pretty simple with this chapter, but as we get into later chapters, we'll talk about making bulletproof applications. What I mean by that is applications that no matter what the user does, they don't crash. Our applications that we enter in this chapter are not going to be bulletproof. They're going to be pretty easy to crash, and I'll demonstrate that for you guys when I'm going through your programs. But then in subsequent chapters, I'll give you some tools to help you fix that. So one of the ways we can get around a text box too small is making a text box multi-line. There's just an option on the text box. You can allow multiple lines of data. For the number of days in this application, you wouldn't need a multi-line text box, but say you were creating an application where the user had to enter a paragraph of notes or something like that, then you would probably want to use a multi-line text box. But the option's there. We're not going to use it in this chapter at all. Maybe later on in the year. There's another kind of text box. Again, we won't use these text boxes with any of the cases in this chapter, but probably in subsequent chapters. It's called a masked text box, and you've probably seen these if you're using applications online where you're entering data in a web form or something like that. What a masked text box allows you to do as a developer is force the end user to enter their data in a certain format. So for example, a date, they have to enter month, month, day, day, year, 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 in four-digit years, or a phone number. Number, dash, then 4 numbers, or a social security number. It just makes, when you're collecting the data, you putting it in a database or something like that, you want the data in a specific format, and masked text box allows you to do that easier. Again, this isn't something we're probably going to have to do in this chapter, but in subsequent chapters, you'll have to do that, possibly. So to create a masked edit text box, you will notice there is a little kind of arrow right here. If you click on that, it'll give you a dialog, and you can click the edit mask that you want to put in there. Date, social security number, phone number, what it is, and it just puts those lines in there. If you want to play around with it later on, you can. Okay, so the first question that I'm going to want you to answer when you're done this, and you can open a Word doc right now, pause this video, is what is the difference between a text box and a math text box? So that's question number one that I'm going to want you to enter to prove that you've watched this video. And there'll be a couple more questions later on in this video, okay? So question number one, what's the difference between a text box and a math text box? Okay, so we're moving on. So the next nice little GUI thing that we have, or UI thing that we have in VB, Visual Studio, for our end users is the accept button and the cancel button. So what that does for us is it allows a quick little shortcut key for the users. So rather than hitting find cost, we can assign the enter button to that find cost button. And it's just a property in the form. So the accept button is enter. So all you do is when you click on the form, you drop down on the accept button, you find the button you want to assign it to, and it'll assign it. So when the user hits the enter key, it will click the find cost button. Just a quick little shortcut for people. And you can do the same thing with the cancel button. There's a cancel button property here. And for example, if you wanted the clear button to be assigned to the cancel button, you could select that in the drop down. I'll show you a little bit more about this when I go through the guided program development. It'll make a lot more sense then, but just be aware that that is there. All right, so users can enter data into a program by using the text box object. When the user enters data, it becomes the value stored in the text property of the object. So remember we dealt with the text property of the form, the text property of the label. The text box also has a text property. Something very important to remember is data entered into a text box is always going to be stored as a string data type, okay? So even if you enter a number into a text box, by default, that data is stored as a string. So if a number is entered into a text box, it must first be converted to a numeric data type before any arithmetic operations are performed. And that's kind of part of the processing that we're going to do. That number is a string automatically in a text box. So anything can be a string. Anything is a string that you enter. But before we perform any math on it, we got to convert that string into a proper number so we can do math on it. So a string data type can store any character or variable in the computer. So anything you enter in the computer can be stored in a string data type. It's the most open, the most available data type that we can use. It also uses the most memory. So you want to avoid it if at all possible. So you want to always store your data in the proper data type. You could store everything in string data type, but that's going to use a lot of memory, and if you need to do math, it's not going to work for you. The data type for the value the user enters in a text box object is stored in a text property. The text box object is always going to be string. I mentioned that in the last slide. A variable is a named location on RAM where data is stored. And the string variable is a named location in RAM that can store a string variable. So this is an example of the code you would write to declare a string variable. So for example, we had that number of days we entered in the text box. So we have to allocate a place in memory. So we would dim, which is our declare statement. It stands for dimension. Our variable name. And you notice our variable name has a naming convention. str because our data type is string. Number of days, just like our objects in our application, we have a naming convention for our variables. So dim string number of days as, and then our data type. Okay, so that's a simple line of code for declaring a variable. So the dim, the variable name, as, and the data type. So just a couple examples of some other simple data types we have. We have string data types, we have integer data types, and we have decimal data types. You can see in this example, string starts with str, integer starts with int, and decimal starts with dec. Okay, just our naming convention that we're going to be dealing with as we go forward. So after we declare our variable, then we want to get the value that is in the text box into that variable. So we have to do an assign statement. So what we do is we take our variable name and we set it equal to the text value of our text box. So text number of days dot text, we set that equal to string number of days. And what that does is takes that value that the user entered in that text box and assigns it to the string variable. And this code would be inside the find cost button. So when you click find cost, it's going to do all this code to assign the value in the text box to the string variable. Here's an example of the whole, or the declaration and the assignment inside the code editor. So this is inside our button find cost click. We declare a variable and we assign the text value of the text box to the string variable. So these are the basic numeric data types that we're going to be dealing with in this chapter. So integers are whole numbers, okay? Sample value for integers is just 48. So any whole number, no decimal points, is an integer. Memory allocation, so that's how much memory each variable is going to hold. It's 4 bytes, so it's a very small amount. And the range of values that an integer data type can hold is this 2 billion, negative 2 billion to positive 2 billion. Okay, so pretty large variables. Most things that we're going to be dealing with as far as whole numbers are going to be able to fit into an integer data type. We have our decimal data types. So decimal data types hold 16 bytes, so 4 times as much as an integer data type. And decimal values may have up to 28 significant digits. So 28 characters long, either a really small number or a really large number. And double is similar to a decimal data type, just takes up less memory. So we're looking at less than 28 significant digits for a double data type. Oops, went the wrong way. So an integer data type holds non-decimal whole number in Visual Basic. An integer variable identifies the location of RAM where an integer value is stored. So if we declared dim int number of days as integer, then we could assign a literal 4 to int number of days. Okay. You can also assign the literal value at declaration. I don't recommend doing that. You can run into problems sometimes doing it. I like to do it in a separate line, but Visual Basic does allow you to assign the literal value at declaration. The decimal data type accurately represents large or very precise decimal numbers. A decimal data type can be accurate up to 28 significant digits. So that's a pretty large number, and I think you remember that was 16 bytes. So kind of a lot of memory that it uses. The double data type can represent huge positive numbers and very small negative numbers. It can include values to the right of the decimal point. Remember, the double is a little smaller. In reality, with the programs that we are working with, it's not going to matter that much whether you use double or decimal. But when you get into much larger programs where you're processing hundreds and thousands of rows, I worked for a while at Fidelity Investments. We were doing stock processing, and we would process millions of transactions a minute. So when you're working with that volume of data, if you use the wrong data type, applications can get really slow. So when you're working with large volumes of data like that, you really want to think about what data types you're using in your programs and how that's going to affect the speed of the programs going forward. Okay, but for the programs we're working on in this chapter, very small programs, memory isn't going to be that big of a deal. But you should still get into the habit of using proper data types when you're working with programs. What you kind of want to think about when you're doing that is, think about what data is going to be going into, what type of data the user is going to be entering in the text box. Would they ever enter a value that's over 1,000,000? Okay, if they wouldn't, then you don't need to use a very large data type. And I'll go through in the subsequent slides some of the other data types we have. There's a lot of different data types. You want to think about which ones are out there and which is the proper one to use for the particular situation. So we have a char data type. That's a single character such as question mark or M, 2 bytes of memory. Boolean data type, that's a true or false value. So there are a lot of situations where you'll want to use Booleans. We're going to be using that in a few chapters down for checking that the users entered proper values in our programs, but you don't have to worry about that yet. So a char data type represents a single keystroke, such as a letter of the alphabet, a punctuation mark, or a symbol. So you could use a string for that. The strings would use a lot more memory. So if you know a user is only going to be entering a single character into a text box, or that's all you want to put in a variable, you can use the char data type for that, or char data type for that. Okay, just some examples of declaring a char data type. So naming convention CHR, and assigning an A. You notice when you're assigning a string, it's in quotes to the char data type, to the char variable here. And below here, example of Boolean declaration, variable declaration, and then a Boolean assignment. So we're just setting that value to true. So a Boolean data variable can contain a value that Visual Basic interprets as true or false. So an example, if you had an application that was looking at a college and if the student was full-time or part-time, so Boolean full-time student true would mean they were a full-time student, false would mean they were not a full-time student or a part-time student. One way you could use it, lots of different ways to use a Boolean. Some of the other data types that we have available to us. So we have a byte, that's a whole number from 0 to 255. Uses 1 byte of memory, so not a lot of memory. A date data types hold dates and times. So that's 8 bytes of memory. Long data type, a whole number, such as 342,534,538. So that is 8 bytes of data. So that's an alternative to an integer data type. I usually tend to use integer rather than long. We have the object data type, which holds a reference to an object, 4 bytes. We have a short data type. So this is, again, similar to an integer data type for values negative 32,000 to positive 32,767. And we have a single data type. And these are whole numbers, again, with a range of, let's see, 3.4 to the 38th power. So that's larger values, 4 bytes of data. So you look at this and it seems like there's a lot to think about. What you really want to think about, so if I'm developing an application and I'm declaring my variables, what's the largest value that's ever going to be put in this variable? And I'll tell you an interesting story about an issue that I ran into at one of my clients that had to do with the short data type. So I was working at one client, and my boss called me and he said, I got an emergency job I need you to do at this company. We hadn't done business with this new company before, but they had a crisis going on. It was actually a Visual Basic program. This was probably 20 years ago. So it's a classic Visual Basic, old Visual Basic version, much different than the version you're using now. But they had this application that wasn't working anymore, and they needed me to come in. So I went over, looked at their problem, and they were getting an overflow error in the application. And this was an application that was used for the state of Arizona. And it was their payroll and billing application. So a bunch of data was entered into this application over the month, and at the end of the month, they would run payroll and billing. So they had tried to do that this particular month, and it stopped working, and they were getting an error, and they had no idea what was going on. And this application was built for them by a consulting company, and the consulting company wasn't around, and the company didn't have anyone on site that was comfortable using the application, so they brought me in to take a look at it. So I, opened the application. They showed me where the code was, and I said, "So what's happening? Where's the error coming up?" And they said, "Well, we're trying to run payroll, and we're getting an overflow error. So we're assuming there's some variable that's declared improperly or something like that." So I started looking through their code, and there was probably 500,000 lines of code. It was a very complicated program. So I looked at their database, and as I was scrolling through their payroll table, I noticed that the last payroll record had an identifier on it, and the number was 32,767. And I didn't know specifically what the issue was, but something rang a bell with that number. I said, I don't know what it is, but something about that number reminds me of something. I didn't know that it had to do with a short variable. I don't memorize the range on these variables, but it rung a bell that there was something going on. So I started looking at their code, and inside their code, they had declared the payroll ID number as short. So what had happened is they had, over the course of 2 or 3 years, they had processed 32,767 payroll records, and they were trying to process the next one, which should have been 32,768, and they couldn't because the variable couldn't hold one more value. So all I did to fix their problem was redeclared that variable as integer, recompiled their program, gave it to them, and their program started running. Took me probably all of 15 minutes to fix the program, but they thought it was the greatest thing in the world that I was able to fix it. So very simple thing, just redeclared the short variable as integer, recompiled the program, gave it back to them, and their payroll started running. They were able to bill their clients, and they actually kept me on there for a couple of years to work on other issues they were having with that program and other programs. So it was a good thing for me. So the second question that you're going to have to answer in this chapter is, what was the issue that I just mentioned in this in my previous story that I told you what the client was at? What was the issue I encountered and with the short data type, and how did I resolve it? Okay, so that's your second question you have to answer for me in this chapter. Okay, so when we are declaring our variables, this is a naming convention we're going to use. For strings, str, for integers, int, for decimals, dbl, and for doubles, dec, for doubles, dbl. So the rest of these we probably won't be using in this chapter, but you have a reference to go back to in the book so you know which ones to use when you get to it. And you can always ask me if you're not sure of the variable prefixes. So these are our naming conventions, just like we have on our objects. So literals. A value is called a literal when it's literally the value that is required by the assign statement. So if we set a variable name equal to 104, that 104 is the literal value. Okay, if we set a name to a string variable, poly, this is our literal value. So literal is just literally the value you're putting in the assign state. Sometimes you might want a literal to be a different data type than the VB default type. So in that case, use a literal type character on the declaration. So if we wanted to force this, this variable to be a short, you just put an S after the literal. Same with integers, you can put an I there. Decimals, you put a D. Doubles are R. I have no idea why you would make a double an R, but that's what it is. And a character is a C. They may require you to do this in the chapter walkthrough. Sometimes you might need to do it. It's not always necessary, but there are examples later on in this book where you will want to use forced literals. A constant contains a permanent value throughout the execution of a program. So when we declare something as a constant, instead of a dim statement, we have const here, and then we have to set the value at declaration. So we use a C in front of it to say it's a constant, then our decimal naming convention, price per day as decimal, and then we set it equal to 9.95 decimal. So what it means as a constant is this value can never change. Once we've set it, can't change that value. If you try to, you'll get an error. Okay, and there are times when you might want to do that. It's something very important that you don't want the program to actually change, but accidentally change while the program's running, or a developer to actually accidentally change that number. You can set it as a constant. You know that value will never change in your program. So the declaration of a constant begins with the letter const instead of dim. You must assign the value to be contained in the constant on the same line as its definition. You cannot attempt to change the value of the constant anywhere in the program. If you do, you'll produce a compiler error. The letter C often is placed before the constant name to identify it throughout the program as a variable that cannot be changed. So it's just a nice thing to have in there so that your other developers that are looking at the program, or yourself, know that that's a constant. Just a naming convention thing. Other than the C, constant names are formed using the same rules and techniques as other variable names. Program becomes easier to read because the value is identified by the name. If you discover the value must be changed, then the code is much easier and more reliable to change the value one time, and the constant is supposed to changing every occurrence of the value in the literal. So it's a good idea to, if you're using variables somewhere, you set it once and not do it multiple times in the program. So when a variable is declared, it will be underlined with a green squiggly line until it is referenced in a statement. So you might remember or recognize this from like Microsoft Word or Google Docs. Sometimes when you spell something wrong, it'll put a red squiggly line under it to show you that it's misspelled. In VB, if you have declared a variable and it hasn't been used yet, Visual Studio will put a green squiggly line under that variable, just to tell you that this variable is here, but it's not used anywhere. Okay, so if you get done running your program and you've got a bunch of variables with green squiggly lines in them, that means you haven't used those variables and you probably don't need them. When using a variable in a program, it's mandatory that you define the variable before using the variable name in a statement. Okay, so if you do something like this, assign your text block value to the string variable, then declare the string variable, that's going to cause you an error. This declaration statement has to come before you're using the string variable. So that the variable declaration always happens first, otherwise you'll run into an error. The scope of a variable specifies where the variable can be referenced in a Visual Basic statement within the program. You declare a variable in the region within a program. The code between the substatement and the end substatement is a procedure. A variable that can only be referenced within the region of the program where it's identified is called a local variable. Local variables have a certain lifetime in the program. Global variables can be used in multiple regions of a Visual Basic program. So if you declare a variable inside your button click subprocedure, that variable can only be used in that button click procedure. It can't be used in your exit button, can't be used anywhere else in the program, or in any button in the program. If you want to use a variable that can be used anywhere in the program, it needs to be declared at the class level. So above all of those, or outside of all of those subprocedures. Global variables use a lot more memory, so you want to avoid them if at all possible. There are times when you do need to use global variables, make a variable available everywhere in the program. But if it doesn't need to be used everywhere in the program, you should declare it locally only where it needs to be used. Okay, again, because a global variable is going to use a lot more memory than a local variable. So let's talk about converting data. Visual Basic includes several procedures that will allow you to convert one data type to another data type. The procedure to convert string data type to an integer data type is called toInt32. The procedure is in the convert class, which is available in the Visual Studio 2017 class library. The procedure that performs its task but does not return a value is called a subprocedure. So you guys have been developing subprocedures all along. You just didn't know your button click, that's a subprocedure. A procedure that returns a value is called a function procedure or a function. And we'll, in a few chapters from now, we will start defining user-defined functions. But this chapter, we're going to be using some built-in functions with Visual Basic. An argument identifies a value required by a procedure. Every procedure is part of a class. Okay. So in this example, we're going to be using the toInt procedure that is part of the converse class. So what this is going to allow us to do is convert the string number of days, which is a string because you've entered it from a text box, and we want to do some math on it. So we have to convert it to an integer. So this toInt32 procedure is going to take that string and convert it to a number for us. And we're going to assign that number to an integer variable rather than a string variable. So convert is our class, toInt32 is our procedure. Our variable for our string number of days, this is our argument. String number of days has a value of 4 in there, and we're going to assign that to a variable, which I think you'll see an example of in the next screen. Yeah. So convert toInt32, argument, string number of days, and that assigns this string number of days variable to our integer value. So by default, Visual Basic will automatically convert data types if the one on the right side of the equal sign is an assignment statement is different from the data type left of the equal sign. To prevent automatic conversion of values, a developer must insert the option strict on statement in the program prior to any event handler code. The option strict on statement explicitly prevents any default data type conversions that would cause data loss and prevents any conversion between numeric data types. So if you do not have option strict on, you can just say int number of days equals string number of days. VB will allow you to do that. It's not a good idea to do that because Visual Basic is making a guess on how to convert those variables. We want to force it to convert it the right way. If you do it incorrectly, you can lose data can get stripped off, you can lose precision. So for the next couple of chapters, we're going to keep option strict on in all of our programs and do these conversions. Later on in the chapters, once you get used to conversions and used to data types, I won't force you to have option strict on in your programs, but moving forward in this chapter and the next chapter, I'm going to require you to have option strict on and do this conversion. And if you give me your programs and they don't have option strict on, I'm going to turn option strict on and then it'll make your program not work. So that's very important to keep option strict on your programs, and I'll show you how to do that in the guided program walkthrough. So to turn option strict on, it's just this line of code. You put it right above the public class, and that forces you to put in those conversions. If you don't put in those conversions, you're going to get errors in your program. And it's important for you to do that initially when we're first learning about data types. Okay, so the next thing we're going to talk about is arithmetic operations. So some of the simple arithmetic operations we'll be dealing with: addition, subtraction, multiplication, division, exponents, integer division, and modulus. These are all the examples of the operator you use in Visual Basic to represent those. So plus, minus, asterisk, forward slash, little caret, backslash, and modulus. And we'll talk about these in details in the next couple slides. Just some simple math. It's, nothing more than that. So the addition arithmetic operator plus adds the numeric values immediately to the left and right of the operator and replaces the arithmetic assignment in the assignment statement. So we have three variables here, all decimal data type. So we're adding price plus tax, and we're assigning to the decimal total variable. Pretty simple, nothing more complicated than that. Almost like algebra class. An arithmetic expression that uses the addition operator to contain more than two numeric values to be added. In addition to variables, arithmetic expressions can contain literals. So we don't have to have just two values here. You can have more than 3, 4, 5 variables. Obviously, if you have 20 values you're adding, you probably want to break it up into a few lines or use a loop, but we'll get into that later. You can also use a combination of variables and a literal value in here to assign the value. We have subtraction, kind of same concept. Subtract one value from another in an assignment statement. Visual Basic uses the subtraction arithmetic operator with just a dash. Nothing more complicated than that. Multiplication is accomplished through the use of an assignment statement and the multiplication operator, which is an asterisk. So int land plot length by plot width. Multiply those, and we're assigning it to plot area. So length times width equals area. Nothing complicated there. Visual Basic provides 3 arithmetic operators for division and related calculations. So this gets a little more complicated, and you can get yourself into a little trouble if you use the wrong backslash here. So we have the slash, the backslash, and the mod. So the backslash is for integer division. With integer division, the quotient is returned from the division as an integer. So it's not going to return a remainder. It's just going to return the first value. It's going to knock off that remainder. And modulus does just the opposite. Modulus will return just the remainder. And it explains that the mod operator divides the number to the left of the operator by the number of the right and returns the integer value that is the remainder of the division operator. Probably not going to have to use modulus or integer division in this chapter, but in subsequent chapters you probably will, so it's a good idea to know that they're there. So we've got division, regular division, which is a forward slash, integer division, which is the backslash, and then modulus for getting our remainders. So lots of variables here, or lots of options here for doing math. So exponents means raising the number to a power. It's accomplished in Visual Basic using the little caret, which is, I think, let me look at my keyboard, above the 6. So if you wanted to get the exponent 3 of the length of a cube, you just use the caret like you would any other arithmetic operator, and it's going to raise that number by the power of 3. And you can do exponents on fractions just like you can anything else. Obviously, you can do multiple applications here. You can combine pluses and minuses. But keep in mind there is an order of operations, just like in math class. Exponents are performed first, multiplication and division next. Integer division follows that, then modulus. And addition and subtraction are always performed last, just like math class. Within these 5 steps, calculations are performed to left and right. And if we put parentheses in there, everything in the parentheses is done first. Okay. So if you have sub parentheses, things inside the parentheses, you can group them together just like in math class. So once we've declared our variables, converted our variables, and run our arithmetic on them, the last step is to get the data out of those variables and output them back to our user. And what we're going to do is put those values in a label. So to do that, we've got to convert our number from a decimal or to an integer back to a string, because whatever we put in a text box or a label has to be a string. So we're going to take that, in this example, it's a temperature that's in a decimal variable, convert it, again, we're using our toString function, we're going to convert it to a string, and we're going to assign it to our text value of our label. So that's going to take whatever value is in this variable, could be 100.5, and it's going to convert it to a string and assign it to that text value of that label for us, and output it in the program. We can also do some format specifications, and this is kind of just a nice GUI thing to do. For instance, if you're outputting a currency value, you're going to want to put the $ and 2 decimal points in there. If we put within that toString, within the parentheses, a C, that's going to automatically convert that string in this format. Same with general. Displays the number as it is general, so that doesn't really do much for us. Fixed will set it to 2 digits. Number will be 2 digits by default, but you can actually put a F2 here, or 2 would put 2 decimals. You could put fixed 3, 4, 3 decimals. 5 would put 5 decimal places here. If you put a P in the toString, it's going to put a percentage in there. Just puts a percentage after it. And then scientific notation is an E, and it'll format our very large numbers as scientific notation for us. So this is just kind of some GUI stuff, makes it easier for us just to display the data in the proper format that it should be. Does the rounding for you, does all the formatting for you, makes it really simple. So just a couple examples of outputting a sample decimal numeric value using these different format specifiers. So the first one, currency 2. So you really wouldn't need the currency 2. It would be the same as just putting a C in there. So this displays a number as currency with 2 decimal places. If you put a currency 3 in there, it's going to display 3 decimal places if the value has 3. F1, fixed 1 decimal place. Numeric 4, so you notice the difference between F and N is there's a comma in the N, there's no comma in the fixed. And then percentage 0, so they're displaying that same number as a percentage with no decimal places on it. So it's just some nice UI stuff for our users for outputting our data in our label when we're done with our processing. So the last thing you're going to have to do with your guided program walkthrough and all the programs in this chapter is allow the users to clear out the values in the text box in the label. If they want to enter or use the application multiple times, you're going to allow them to clear out those values. So the clear button of inhaler must complete the following tasks. You have to clear the text property of the text object, clear the text property of the label object that displays the total cost of bikes rented, and set the focus of the text box object, which means placing the insertion point in the text box. So the focus is just where that little blinking cursor is going to be. So the user doesn't have to click on the text box and enter a value. That the focus is already on the text box, so the user can just type a value in there without clicking on it first. So there is a clear procedure built into the text box. So if in code you just type in txt text box or the text box name.clear, that will clear out the value in the text box for you. So that's a built-in function that's part of or a built-in procedure that's part of the text box. Really nice way to just clear out the value there. For some reason, the label doesn't have the same function. If you want to clear out the value of the label, you've got to set the value equal to quote, quote, which is assigning it to nothing. I don't know why they have a clear procedure for a text box, but not a label, but that's just the way it is. So setting it to quote, quote is setting it to null or setting it to nothing. So I mentioned in the previous slide setting the focus. So setting the focus is just putting the insertion point right in the text box. And to do that, it's another procedure, which is the focus. So you would just type in txt number of days dot focus, and you would probably do that in the form load, which we'll talk about in a few slides what the form load does for us. So whenever you wanted it to happen, in our case, we want it to happen when we hit clear or when the program starts. So as soon as the program starts or as soon as the user hits clear, the focus goes right back to that text box. So a form load event occurs when the program starts and Windows Form Objects is loaded into computer memory. So the event handler completes the following tasks. So in your program, this is what it's going to do. You're going to display the cost per day in the byte heading, clear the placeholder from the label cost text property, and set the focus on text number of days text box. So some other things you might want to do in the form load event. Say you had a program that had a drop-down box and it got populated with a bunch of values from a database. You would want to load those values from the database in the form load event. So when the person opens up the program goes out, gets all those values it needs, puts them in the drop-down value or the drop-down box. So when the user clicks on it, those values are there. So that would have to happen before the form opens. So that's in the form load event. We'll get into that much later on in the year, working with databases. So concatenation. Let's talk a little bit about what concatenation is. Process of joining two different values into a single string is called concatenation. The values being concatenated must be string data types. So concatenation is taking two string values and kind of putting them together. So in this example, we're taking a value in a decimal variable, and we are concatenating. Concatenation, the character for concatenate is the ampersand, a string called per day for 24 hours, okay? So we're taking two values and putting them together in code for us. So we take 995, use the ampersand, and then we put per day, and that concatenates two different variables. So if I go back to this slide, this wasn't originally a string, it's a decimal, but we apply the toString character to make it a string. This continuation character is just because we're continuing this on a second line. So if you took this code right here and put it up here and got rid of that, you could do it. They just did it for space here, and you can do that in your code as well. If you have a line of code that needs to go into multiple lines, you use this continuation character and it lets you go into multiple lines. I don't recommend doing it. I think it makes your code a little messy unless you have a really, really long line of code. So the last question that I want you to answer for me after watching this presentation is define what concatenation is in programming. Okay. So the next thing we're going to talk about is class scope. When a variable is referenced in two different event handling procedures, it must be defined at the class level instead of the procedure event handle level. So in this example, our constant is going to be used in our clear button and in our find cost button. So, So we are not declaring that within our button, we are declaring it right below our class, so it is available everywhere. So it's not a global variable, but it's a class level variable. If we wanted to make it a global variable, we would have to define it somewhere else in the program to make it available everywhere. But it's global to this form, but not global to the whole program. So we call it a class scope level. And we'll get into scope and explain it a little bit more when we go through the guided program walkthrough with you. So the next thing you're going to have to really dig into in this chapter is debugging your programs. You're probably going to be getting some format exceptions. So format exceptions occurs when the user enters data the statement within a program cannot process properly. So if you do your sign statements, you try to convert things the wrong way, you're going to get an exception error. And Visual Studio does a really good job with giving you some kind of recommendations when you get exception errors. So it'll give you some hints. This is what I think the problem is, and this is how I think it'll fix it. Doesn't always do it 100% correct, but usually it's going to do a pretty good job for you. So it'll help you out when you get the errors. Format exceptions, you might get some overflow exceptions if you're declaring your data types improperly. And when I look at your programs, I'll show you how easy it is to crash these programs, but we'll work on fixing them later on in the next chapter and other chapters after that. So an overflow exception occurs when the user enters a value greater than the maximum value of the statement can process. I mentioned overflow exceptions when I talked about the issue I had at that company I was working with, where they declared something as short, so they got an overflow exception. So they're trying to put a variable, a value in a variable that couldn't handle a value that large. It's also not possible to divide by 0. So if your program contains a division operation with the divisor is 0, the divide by 0 exception will occur. So if you're doing some math and you don't declare a variable, or you have 0 in the divisor, you're going to get that error. So this is an example of the requirements for the guided program walkthrough. So it's the bike beach rental application. The purpose of the program is the bike beach rentals programs allow the user to enter the number of days they intend to rent a bike. The program calculates the total cost of the bike rental based on the price of $9.95 a day. In a Windows Classic desktop application, the user enters the number of days to rent the bike. The program calculates the total cost of the bike rental. The user can clear the values in the screen and enter a new value from the number of days the bike is rented. So our algorithms processing conditions, the user must be able to enter the number of days the bike is to be rented. The user can initiate the calculation and display the total cost of the bike rented. The application computes the total cost by multiplying the number of days by the cost per day. Cost per day is fixed at $9.95. So we're going to put that in our constant. The nice thing about that is if it changed, we would just know exactly where that is in the program, change that value. If the price goes up for whatever reason, it's there in one place in our program. We don't have to change it in multiple places. The total cost of the bike rental is displayed as a currency value, so that's when we output it. The user should be able to clear the value entered for the number of days and the total cost of the bike rental, so that's that clear button you're going to be creating. And the user should be provided with a button to exit the program. And the image that you're to use for this chapter is provided on your flash drive. I gave it to you. If you need it, just reach out. And that's it for this chapter. So make sure you enter those 3 questions that I mentioned in a Word doc and reattach them to the assignment. That's it. Have a good day.